What's up, pre-calculus? Super excited to be here, right? Right? Stick around, it's not, we're gonna learn some trigonometric equations, not too triggy. Super excited to do some math today. I'm Mr.Creasman. You're here today to learn how to solve trigonometric equations, okay? And I'm gonna make this pretty short and concise. This is for my pre-calculus class, but after COVID-19 and coronavirus, we are now here online learning how to do math. And it's only 2.5 hours a week worth of work. You only have one assignment to do this week, I believe. I'll let you know everything on Google Classroom. But if you're just someone random here on YouTube trying to learn how to solve trig equations, feel free to stick along. I'm gonna show you what's up. It's just like solving our normal algebra from Algebra 2, right? It's just an equation with a variable, isolate it to one side, and then solve for x. You're gonna take an inverse trig function at the end. It's pretty straightforward. So have your unit circle handy, have your trig reference sheet handy. That's gonna be your best friend. That was probably mirrored for you guys, but whatever. Yeah, so as we're doing notes, if you think I'm going too fast, just pause the video. It's a YouTube video. Pause the video, copy down my notes, that kind of thing. If you have any questions, leave a comment, that kind of thing. I'll get to it. This is my job. I'm getting paid to do this. So it's gonna be super fun, and if it's not fun, this is Tam. Sorry, he was sleeping. First thing that you need to know is that a trigonometric equation can have one solution or no solutions, right? Just like normal equations. So
you can have 1 or 0 solutions.
There's only one more thing that you need to, well, you need to know a million things, but there's only one more thing that we need to know right now, and that is that to solve a trig equation, we just isolate the trig functions, okay?
Sorry, I know my handwriting is beautiful.
Now, if you're in my pre-calculus class, I realize you probably already have these notes. Okay, this is just a review, so if you don't want to do the review, just skip to the end. Okay, so first, let's solve by isolating the expression. So let's just take this little example. So first, let's solve by isolating the trig expression. So let's say 5 cosine of x plus root 2 equals 3 cosine of x, and the domain here is -infinity to infinity. Okay, so the first thing, we'll talk about this domain in a second, but the first thing that we're going to do here is, remember what I said a million times, isolate the trig functions, right? So what's the trig function? Remember trig function, sine, cosine, tangent, cotangent, all that stuff, cosecant, secant. So where do we see a trig function? Right there and right there. So let's isolate them. How do we isolate them? Right? What does isolation mean? It means solitary confinement, that kind of thing. So we get them over on the other side. So how would I get this cosine x over to this side? Right? Well, this is positive 3 cosine x. I'm trying to solve for, I'm not trying to solve, I'm trying to isolate this over there. So what's the additive inverse of 3 cosine x? That's negative 3 cosine x. Right? If 3 cosine x minus 3 cosine x equals 0, but I have to do it over to this side, and why don't I do it over right next to this guy? Because that's like 5 apples and negative 3 apples, you just combine those. So we get, what's 5 cosine x minus 3 cosine x? That is 2 cosine x. We didn't do anything with the root 2. And what does that equal over here? That equals 0 over there. Okay? I'm doing good. When I isolate stuff, I always get stuff on the left side. Okay? Now, I'm still trying to isolate this. Right now it's not isolated because it's next to this positive root 2. How do I get rid of that positive root 2? Thank you very much. We subtract root 2. So you subtract root 2 to both sides. What's 0 minus root 2? That's just root 2. So we have 2 cosine x equals negative root 2. Now, I still have not completely isolated the trig function. Why? It's not just a trig function. Right now what we have is we have 2 times a trig function. So how do I isolate that? Good job, I got to divide by 2. You're so smart. So this is 2 times cosine, so I divide by 2. That cancels that guy off, and I divide by 2 over here. Now I've completely isolated the trig function, right? I have cosine of x equals negative root 2 over 2. Now, who knows what we need to do? Thank you very much, Gabby. We need to take the inverse sine of both sides. We need to take the inverse cosine of both sides because we're solving for x, right? So we need to get x by itself. So to get x by itself, I do the inverse operation of what's happening to x. What's the inverse operation of cosine? It's cosine inverse. So what I'm doing here is I'm taking cosine inverse of cosine of x. And what does that equal? That equals, if I do it to this side, I have to do it to that side too. Cosine inverse of root 2 over 2. Or negative root 2 over 2. Okay, so the cosine inverse of cosine equals 1, right? Because anytime you take an inverse and throw it at something that is the same thing, it just cancels each other's out, right? So that equals just x. And what does this equal? What is the cosine inverse of negative root 2 over 2? Well, let's think about that. We gotta ask ourselves a question here. What angle on the unit circle has a value of negative root 2 over 2? Let's write that down. This is saying, or this is asking,
what angle on the unit circle has a cosine of negative root 2 over 2? Right? That's what cosine inverse is saying.
Okay, well, let's look at the unit circle. You know that root 2 over 2 is the values of what? It's always going to be those 45s, right? I'm just going to do this once. I'm not going to do it for all of them.
So we have, right here we have positive root 2 over 2, positive root 2 over 2. Right here we have negative root 2 over 2, and root 2 over 2. Right here we have negative root 2 over 2, and negative root 2 over 2. You get the idea, right? Over here we have root 2 over 2, and negative root 2 over 2.
Remember, the cosine is the x value, the sine is the y value. So which one of these has a cosine of negative root 2 over 2? It would be this one, right? But it would also be this one, because the x value on both of these points is negative root 2 over 2. Okay? So what's the actual angle up here? That'd be 1 pi over 4, 2 pi over 4, 3 pi over 4. So we have x equals 3 pi over 4, and x equals, what's this value? So it'd be 4 pi over 4, and then 5 pi over 4. Okay, but we're not done, because what was our original domain? All the way up here, it was negative infinity to positive infinity. So remember, on the unit circle, this is just one time around the unit circle. When we look at the full circle, it's just one rotation. We can do a million rotations. We could go one, we could then keep going to 2 full rotations and then 3 full rotations. So this angle can be multiplied by any scalar by any scalar factor. So it's not just 3 pi over 4. It could be 3 pi over 4 plus 2 pi, right? Because we could do a rotation. So the final answer is actually x equals 3 pi over 4 plus, what's the full rotation? The full rotation is 2 pi, but let's just put an n here. The reason we're putting an n there is because we can do however many full rotations that we want. We could do 5 rotations and still be at that angle, so we could go 1, 2, 3, 4, 5, or we could do 10 rotations. Any number n. N could be 100, n could be 0, n could be 1, right? It's whatever it is. And we also have and x equals 5 pi over 4 plus 2n pi. Okay, so like I said, pre-calc, you already did all these notes, and if you just want to go to your homework, that's fine. You don't have to show me notes for this week, since this is a review, all right? I'll post that on the Google Classroom. You just have to do your homework. That's all you gotta do. I'll do one problem on your homework tonight, all right? And you're not gonna do odds or evens, you're gonna do all of them, okay? Because it's just one assignment this week. That's gonna be worth 2.5 hours. It's not gonna take you 2.5 hours to do it. If it does, then talk to me and we'll figure it out, okay? All right, let's keep solving these. Okay, so there's obviously different ways that we could factor them, right? I'm telling you that this was factoring by isolation. We isolated it. But there's multiple different ways that we can solve these equations, all right? So another way that we can solve them, and this is up to you to decide when you see one of these on your homework, is you have to decide, am I gonna solve this by factoring? Am I gonna solve this by isolating? Am I gonna solve this by using basic identities? I'll give you a couple examples of each, but let's solve this one by factoring, okay?
This is problem, what is this? This is problem.
Let's do problem 11 on the notes. And so obviously we would still try to isolate, but we're gonna see that this is a squared cosecant and this is just a cosecant. So I can't combine these two automatically, but we're gonna factor this just like we would in Algebra 2 or Algebra 1, so pretty straightforward. So I'm gonna get this cosecant over to this side. How do I do that? I add cosecant squared to both sides. All right, now I'm gonna rewrite this. I have cosecant squared plus cosecant, and I have a 5. And that's all, oh wait, and we still have that 7, so let's just subtract that 7 over. So we get -7. So now we have cosecant squared theta plus cosecant theta plus 2, and that equals 0. Now, how do I factor this? I factor this by thinking of two numbers that multiply to 2 and that add to 1, right? Because you're thinking of this cosecant as your variable x. So like, say I did this to make it a little easier. So I say, let cosecant theta equal x. You don't have to do this. You can skip this step. This is just that you see it, right? So this is just x squared plus x plus 2 equals 0. And if you're in pre-calculus, you should know how to factor that, all right? So that would just be x, and what would we get? We would get 2 times 1. I'm a dummy. That would be negative, and that would be negative. So what we're going to do to factor that is we're going to get x plus 2 and x minus 1. So that'll give us -2 and +1. But this still equals 0. And now we have as our solutions x equals -2 and x equals 1. But what did we let x equal? We let x be cosecant. So what we have now, if we revert back to what we started with, is we have cosecant of theta equals -2 and cosecant of theta equals 1. Sometimes it's easy just to, you're allowed to do this, this is math, you're allowed to say, hey, just let cosecant of theta equals x, but that way it's just a little easier to see, because we've done these problems before. But now you just have to remember to transition back, and actually you do this kind of thing a lot in calculus, where you like let it equal something else, like a different variable, so that it's a little easier to see. So now what we're going to do is we're going to solve this equation for theta. We have cosecant of theta equals -2. So what do I have to do? I have to take the cosecant inverse of both sides. So I get cosecant inverse of cosecant of theta equals cosecant inverse of -2. And then I also get
cosecant inverse, I'm doing this a long way just to show you what's happening, of theta equals cosecant inverse of 1.
those cosecants cancel, So I just get theta equals cosecant inverse of -2. And I also have those ones canceling. So I get theta equals cosecant inverse of -1. You can't leave it like this, just actually figure out what's the cosecant of -2. So remember, this is saying
what angle on a unit circle has a cosecant,
which is 1 over sine of -2 and of -1. Right? So, if we look at the unit circle, what angle has 1 over sine equals -2? Well, let's just start in the first quadrant. We know that this angle right here is √3 over 2 and 1/2. None of those are going to work because I'm negative and I need a negative. And also, if you remember, our domain all the way at the top was 3 pi over 2 to 2 pi. So we know that we have to be in the fourth quarter, or the fourth quadrant. Excuse me. So we're here because this is 3 pi halves and this is 2 pi. So we know that we're going to either be this angle or that angle. We're not going to be this 45-degree angle because it's asking us for -2 and -1. Right? So this is a positive 1/2 and negative √3 over 2.
and this guy is positive √3 over 2 and negative
1/2. So which one of these? Sine, well, cosecant is defined as sine, so I have to take the y value and I have to invert it, all right? I have to put it over 1 or under 1 because cosecant is 1 over sine. So 1, let's try this one, is 1 over √3 over 2. Does that equal -2? No, I can already tell you it's not going to, because you're going to have to copy dot flip, and you're going to get 2 over √3, and that's just not going to work when you will do it up here. Yeah, it's not going to work. So it's not that one. So let's try this one. If I take 1 over -1/2, what do I get? Well, I multiply by -2 over 1, that cancels out those 2's. Then multiply by -2, and I get -2. Right? So it's this angle. Well, what is that angle on the unit circle? That would be 11 pi over 6. Yep. So theta equals 11 pi over 6. And now we have to figure out this one, -1. Yeah, sorry, I made a mistake here, guys. Always good to write all your work out so you can see where you make mistakes. This isn't a -1, that's supposed to be a positive one, right? Because we solved it up here. X equals 1, cosecant theta equals 1, so it'd be a positive 1. This would also be a positive 1. So we're trying to think of which angle here, in between here and here, has a cosecant of 1. None of those angles are going to give us a cosecant of -1, right? So this is one of our solutions. And what's the other solution? Right? Well, theta equals cosecant inverse of 1, and that doesn't exist in our quadrant. So what does that tell us? There's no solution, right? Okay, so this is our only solution. It's not asking me for the domain of infinity to infinity. I'm not allowed to keep going around the circle, all right? It's saying we stop, we're here, we're in this quadrant. We're only in this quadrant, okay? So when a problem is like this, and it gives you a specific place on the unit circle, you don't put 2n pi. But when a problem is like this, and they're giving you a domain of infinity to infinity, you can go around that circle however many times you want. So in your solution, you put plus 2n pi. Cool? Alright, so now what we're going to do is, when we're solving trig equations, there's multiple different ways that we can solve them, right? So another way that we can solve them is by
using sum and difference identities. Right?
You can use all of your reference sheet identities, right? Our trig identities, that's very handy. And if you see a problem that has a sum of an angle or a difference of two angles, just input it in there and then you'll be able to solve it, right? So let's do problem 19 on the notes.
So we have sine of pi over 6 minus beta minus cosine of pi over 3 minus beta equals root 16 over 2, and our domain is 0 to 2 pi.
So we know our answer isn't going to have plus 2 and pi. It's going to be anywhere in the unit circle, and it's staying in that first revolution. All right? So this is a difference of angles, and this is also a difference of angles. Right? So you're just going to use your reference sheet, your trig identities, and you're going to plug this in there. Okay? So what you're going to get is you're going to get
sine of pi over 6.
That's good news because we know what the sine of pi over 6 is, and we can just evaluate that.
And we're going to get cosine of beta minus cosine of pi over 6. That's good news because we know what that is. We can just evaluate it. Sine of beta. And then we're also going to do all of this guy. It's a little messy, but it's not bad, I promise. So we're going to do cosine of pi over thirds. We know what that is. We're good to go. Cosine of beta plus sine of pi over thirds. Sine, oh shoot. And what does that all equal? That all equals, up on the top we still have that equals root 6 over 2. Oh, sorry, I don't know why root 16 over 2 over there. Yeah, the problem says root 6 over 2.
Okay, so now we're just going to evaluate this. What's the sine of pi over 6? You should know that. It's 1/2. And that 1/2 is going to be there right next to cosine of b. And then we have, what's the cosine of root pi over 6? That's just the first angle in the unit circle. We know what that is. It's root 3 over 2 times the sine of b. Okay? And all of that is being subtracted by cosine of pi thirds. We know what that is. That's just 1/2 times the cosine of beta. Now we have plus sine of pi over thirds. What's sine of pi over thirds? We know that. It's on our unit circle. That is just root 3 over 2 times the sine of b, or beta. I'm going to switch to a darker pen because my pen's run out of ink. Now, that all equals root 6 over 2. That one's not good either. Now we're going to evaluate this a little bit more. Okay, how can I evaluate this right here? Okay, well, these parentheses are being separated by a subtraction sign. And notice that this is positive 1/2 cosine beta, and if I distribute this negative inside here, it's going to make this negative 1/2 cosine beta. So those are going to cancel each other out, yeah? So those cancel each other out. This one with this one. And then what do I have here? Well, if I distribute this negative inside here, I get negative root 3 over 2 sine of beta plus, well, that is being distributed, so I get also a negative root 3 over 2, and that is a sine of beta, and that all equals root 6 over 2. Now check it out. This is just two of the same things, right? So how do I do this? Well, this is just one of these things, and this is another one of these things, so that equal negative 2 root 3 over 2 sine beta. That equals root 6 over 2. So what do these two do? So they cancel out. So I get negative root 3 sine of beta, and that equals root 6 over 2. Still trying to solve this trig equation, so now I have to divide by root 3. That's never fun, so now I get... Alright, so at this point you're just going to divide by root 3. This is just some algebra skills. Okay, so if I divide by negative root 3, what I'm going to do is I'm going to do this. I'm going to have sine of beta equals, I'm going to break this 2 off, so I get 1/2 times root 6, and I'm going to divide by my negative root 3. Now check this out. If I'm doing a radical on the top and the radical on the bottom, I take the radical of the whole thing. So I get sine of beta equals 1/2 times negative root 6 over 3. 6 divided by 3 is 2, so I get sine of beta equals 1/2 times negative 2. So that just equals negative root 2 over 2. Just did some algebra right there. Now, what do? I take the sine inverse of both sides, so I get beta equals sine inverse of negative root 2 over 2. Now I'm just looking on the unit circle. This is negative root 2 over 2, so I knew I either have to be here at that 45 or at this 45. Oh wait, no, I'm in sine. So I was thinking cosine. So since my sine is negative, right? I either have to be here or I have to be here at this 45, right?
So the coordinates here are negative root 2 over 2, negative root 2 over 2. The coordinates here are the same. Well, not the same actually. They're negative root 2 over 2 and positive root 2 over 2.
Okay, so which one of those has a sine of negative root 2 over 2? Yep, you're so smart. It's this one. And what's the angle here? Well, this is 4 pi over 4. That's 5 pi over 4. So beta equals 5 pi over 4. And I don't put plus 2n pi because our domain up here said we're strictly in between 0 and 2 pi. All right, there you go. That's all you need to know to do the homework, but I'll go ahead and do one homework problem for you just because I'm an amazing guy. All right, obviously we're not going to factor this. We're not going to isolate because we can't really do any of those. We identify that we can use the sum of angles on our reference sheet, and we're just going to input what we do. We do the sum of the tangent of angles, right? The tangent sum of angles and the cosine sum of angles. We input it and then bam, we'll solve it. All right, so you look at your reference sheet and the sum of angles formula gives us this.
Right, we get tangent of x plus tangent of pi all over 1 minus tangent of x times tangent of pi. And then we're going to get cosine of x times cosine of pi over 2. And that's good because we know how to evaluate these things, right? It's already breaking it down for us. And then we're going to get sine of x and sine of pi over 2.
Now, all of this equals 0, and let's just input. What's the tangent of pi? You should know what that is. All right, sine over cosine of pi. Sine of pi is 0, cosine is negative 1. So let's just evaluate all this stuff. We can't do anything with the tangent of x, right?
So that is the tangent of x plus what's tangent of pi? Well, pi has a sine of 0, and sine over cosine, so that's going to just be 0. And then we have 1 minus tangent of x times tangent, this is actually being, tangent of pi, we just figured out, is 0, so that's going to 0 out. We just figured out that tangent of pi is 0, so if we multiply these together, this is just 0 times tangent of x. So that's going to 0 out. So you get 1 plus 0, right? And then we're going to get over here, cosine of pi over 2. What's cosine of pi over 2? Think, quick, let's go, 0. That's going to 0 out, right? Because it's going to be cosine of x times 0. And then we get sine of x. What's the sine of pi over 2? That's positive 1. So smart. That equals 0. So let's just simplify this mess, and this is an easy homework problem. Alright, so we just get tangent of x. And then what do we have? So we have tangent of x minus, or actually, that minus is going to make that plus. So it's going to be plus sine of x equals 0.
So now what do? We still have to simplify this. How am I supposed to how am I supposed to solve for x here? So, well, we could actually do a factoring skill too. Watch, check this out. This is nifty. Remember when we were proving trigonometric identities, we always put everything in terms of sine and cosine? Let's do that right now. So if we put this in terms of sine and cosine, we get sine of x over cosine of x plus sine of x equals 0. Now, bam, you should be able to see what's happening. Pull out a sine of x. So if I factor out a sine of x, I get 1 over cosine plus 1 equals 0. Now what are we going to do? Well, if this times this equals 0, I can set each thing equal to 0. So I get sine of x equals 0, and I can get 1 over cosine of x plus 1 equals 0. Solve that guy. And we're starting off to look good.
We're starting to look good. So I just get x equals sine inverse of 0. And then I'm going to subtract 1, so I get 1 over cosine. What is 1 over cosine? 1 over cosine is secant of x equals negative 1. So I just get x equals secant of negative, or secant inverse of negative 1. Now over here, this one's easier. What's the sine inverse of 0? If you got a 0 on the inner circle, right here, what's the sine inverse? What angle, or what is this asking you? This is asking you, what angle, remember what the sine inverse is asking you? It's asking you what angle on the unit circle has a sine of 0, okay? So, our domain, all the way up here at the top is saying we're in pi over 2 to 3 pi over 2. So we're in between pi over 2 up here and 3 pi over 2. So we're in quadrants 2 and 3. What angle has a sine of 0? This one, pi, right? Because it goes negative 1, 0. And that's your answer. So x equals pi. And what about this one? What has a secant inverse of negative 1? And that's really saying when you take the cosine and put it under 1, what do you get? So if I go over here, it would be the same value, right? Because secant is saying cosine, 1 over cosine. Where is that? Where does that equal 1? Over here at the same spot, right? Or negative 1. Where does that equal negative 1? Over here at the exact same pi. So it's also going to be x equals pi. You don't need to write twice, so final answer, x equals pi.
Alright, we chillin'.
How do you like that, algae? Bruh. Alright guys, on the real though, I'm so thankful to be a math teacher. Like, oh my gosh, you guys are amazing. Great times, great times. Yeah, that's pretty much it. You know what to do. Do your homework. Have fun doing it. Don't forget to like and subscribe.